Blended comments in Mexico, undisclosed additions, compromised concrete performance. Introduction. The quality of cement in Mexico is compromised when using waste materials, fly ash, blast furnace slag, inert fillers like limestone, among others, in inappropriate proportions. This is due to the fact that commercial packaging does not specify the components of the cement, which negatively affects its properties, reducing its physical mechanical performance. This could impact its performance when used in concrete, especially in reinforced or pre-stressed concrete structures. A strong correlation was observed between density and loss on ignition when hypothetically only limestone was added to the cement. However, this relationship disappeared when other additions were present. In Mexico, more than 80% of the total cement produced is sold in bags, and these bags do not define the cement's components on their packaging, making it very difficult to characterize it to know the contents of clinker, pozzolana, slag, or inert limestone filler. To objectively evaluate the properties of these cements and support these concerns with technical data, round-robin tests were conducted between the Universidad Michoacana and the Tecnológico de Monterrey Campus Querétaro to corroborate whether the characterization results of the cement powders could be comparable between both universities. Two tests were performed for this round-robin: density and loss on ignition, using identical procedures. Experimental procedure. Ignition test. Weigh the crucibles and add 3 grams of cement to each one. Figure 1. A. Place in the muffled furnace until it reaches a temperature above 900 Celsius and maintains it for 15 minutes. Figure 1b. Allow to cool in a desiccator until the temperature is manageable, then weigh. Figure 1c. Repeat steps 1, 2, 3 until a constant dry mass is obtained. Density test. Place the petroleum in the Le Chatelier flask until it is between 0 and 1. Figure 2a. Place the flask in a water bath at room temperature to stabilize the petroleum level. Figure 2b. Take the initial reading at the bottom of the meniscus. Figure 2a. Weigh a 60-gram cement sample. Figure 2c. Slowly add the cement into the flask to avoid blockages. Rotate the flask to remove bubbles and allow all the cement to settle at the bottom of the flask. Then place it back into the water bath. Figure 2e. Take the final reading at the bottom of the meniscus. Figure 2f. Results. In the following graph, the values obtained by the two universities are shown. Discussion of results. The two tests conducted by the two laboratories yielded very similar results as confirmed by the trendline values y 1.0082x for density and y 1.0272x for loss and ignition. Likewise, the correlation coefficients per R quadrate were 0.9995 for density and 0.9882 for loss and ignition, indicating that both laboratories obtained essentially the same results. This graph shows that higher loss on ignition corresponds to lower density. It is worth mentioning that the 2 points falling outside this trend are apparently due to the addition of calcium clay, as the cements displayed a beige color instead of dark or light gray. Also, the dark gray-filled diamond represents the only CPO-type cement that could be included in the study. Conclusions. While in the United States, ASTM-C 150 sets strict limits on the use of limestone, maximum 15%, and prioritizes the consistency and durability of traditional Portland cement, the Mexican standard NMX C414-11 allows a higher percentage of additions, such as limestone, 6 to 35%, in blended cements, aiming to adapt to local availability and cost conditions. In blended cements, aiming to adapt to local availability and cost conditions. However, this flexibility requires greater technical control, as excessive or poorly managed use of inert materials can compromise the strength and durability of the final product. Most importantly, the safety of the people living in civil works built with such material could be at risk if the cement does not perform its intended function properly.